Welcome to our lesson on forward bias in PN junction diodes. PN junction diodes are fundamental semiconductor devices that allow current to flow in one direction but block it in the other direction. Understanding how they work is essential in electronics. First, let's understand what a PN junction is. A PN junction is formed when a p-type semiconductor is brought in contact with an n-type semiconductor. P-type semiconductors have an excess of holes, which are positively charged carriers. N-type semiconductors have an excess of electrons, which are negatively charged carriers. When a PN junction is formed, electrons from the N side diffuse across the junction into the P side, and holes from the P side diffuse into the N side. This leads to recombination near the junction, where electrons and holes neutralize each other. This creates what we call a depletion region, which is depleted of mobile charge carriers. Due to this recombination, the N side near the junction becomes positively charged, and the P side becomes negatively charged, creating a built-in electric field. Now, let's understand what forward biasing means. Forward bias is when we connect the positive terminal of a battery to the P side and the negative terminal to the N side. This setup applies an external electric field that opposes the built-in electric field of the depletion region. As the external voltage increases, the depletion region narrows, reducing the barrier to charge carriers. When the applied voltage exceeds a threshold value, typically around 0.7 volts for silicon diodes, the depletion region becomes so narrow that charge carriers can flow across the junction. Majority carriers, which are electrons from the N side and holes from the P side, flow across the junction. This establishes a substantial current in the conventional direction from the P side to the N side. Let's look at the current voltage characteristic of a forward bias diode. You can see that below the threshold voltage, very little current flows. Once the threshold is exceeded, the current increases exponentially with voltage. This relationship is described by the diode equation, I equals I sub S times e raised to the power of V over V sub t minus 1, where I sub S is the reverse saturation current, and V sub T is the thermal voltage, which is about 25 millivolts at room temperature. The forward-biased PN junction diode has many important applications in electronics. One of the most common uses is in rectifiers, which convert AC power to DC. Light-emitting diodes, or LEDs, use the energy released during recombination to emit photons. Diodes are also used in voltage clampers, clippers, and as protection devices in circuits. To summarize, forward biasing of a PN junction diode. 1. Involves connecting the positive terminal to the P side and negative terminal to the N side of the diode. 2. Applies an electric field that opposes the built-in field. 3. Narrows the depletion region. 4. Allows for significant current flow once the threshold voltage is exceeded. 5. This current consists of electrons flowing from N to P and holes flowing from P to N. The forward-biased PN junction is fundamental to many electronic devices and applications.